One of the most wonderful things about being a physicist is that you get to think about these absolutely crazy ideas. And one of them that everybody likes to think about is, what about aliens? What if there are these incredibly advanced civilizations out there, way smarter than us, way more technologically advanced? Surely they must have figured out how to go faster than light, right? I mean, if they're that advanced, they could probably just, boost their engines or something and zoom around the universe at superluminal speeds. But here's the thing, and this is what I want to talk about today. It doesn't matter how smart they are. It doesn't matter if they're 10,000 times smarter than us. It doesn't matter if they have technology that we can't even imagine. There is a fundamental law of nature that says nobody, and I mean nobody, not us, not the aliens, not anybody, can go faster than the speed of light. And the beautiful part about this is that it's not an engineering limitation. It's not like we haven't been clever enough yet. It's built into the fabric of the universe itself. Now, I know what you might be thinking. You're thinking, well, Feynman, surely you're exaggerating. I mean, we keep discovering new things about physics all the time. Maybe faster than light travel is possible, and we just haven't figured it out yet. That's a reasonable thought. But let me explain why this particular thing is different. Let me start with something very simple. Imagine you're on a highway, and you're in a car going 60 miles an hour, and there's a truck ahead of you going 50 miles an hour. From your perspective, the truck is moving away from you at 10 miles an hour. You can see that, right? That's just common sense. That's Newtonian physics, and it works fine for everyday speeds. But now let's say, and this is where things get interesting, instead of a truck, we're talking about light. Light travels at about 186,000 miles per second. That's the speed of light, often called c by physicists because we like our little shorthand letters. Now here's the peculiar thing about light that seems really strange when you first hear about it. If you're in a spaceship zooming through space at 99.99% the speed of light, and you measure the speed of that same beam of light, you don't get something slightly less than the speed of light. You get the speed of light, still the same 186,000 miles per second. Does that sound weird to you? It should, because it's absolutely counterintuitive. It doesn't make sense with our everyday experience. But this is what experiments have shown us over and over again for more than a century. No matter how fast you're going, if you measure the speed of light, you always get the same answer. Always. It's constant. And this, my friends, is the beginning of the story. Because from this one observation, this seemingly simple fact that light always travels at the same speed no matter who measures it, everything else follows. All the strangeness of relativity, all the things that seem impossible, they all come from this one starting point. Now let me introduce you to a concept that I think is really important to understand, and it's something that Einstein realized. It's about space and time together. You see, in our everyday thinking, we separate space and time. We think of space as this three-dimensional thing where objects are located, and time as this separate thing that moves forward independently. But Einstein showed us that this is wrong. Space and time aren't actually separate things. They're woven together into something called space-time. Let me try to give you an analogy, though it's imperfect because reality is more subtle than the analogy. Imagine you're standing on a flat desert with nothing around you for miles. You can walk north, south, east, or west, but you're forced to move at one particular speed. Let's say 5 miles per hour. That's all you can do. Now, if you go due north at 5 miles per hour, you don't move east or west at all. If you decide to go northeast instead, you're moving north at some speed less than 5 miles an hour and east at some speed less than 5 miles per hour. You can distribute your movement in any direction you want, but the total speed is always 5 miles per hour. Similarly, you are always traveling through space-time at one particular speed, the speed of light, always, even when you're sitting still reading this very script. But here's the trick. When you're sitting still, you're traveling through time at the speed of light. All your motion is directed through time, and none of it is through space. When you start moving through space, say standing up and walking across the room, you're redirecting some of your motion. You're taking some of that speed that was going through time and using it to go through space instead. So your clock ticks a little slower because you're spending less of your motion budget on going forward in time. This is time dilation, and this is why when astronauts go to space for a few months, they actually age slightly less than people on Earth. It's not science fiction. It's been measured. It's real. It's built right into the structure of the universe. Now here's where the speed of light becomes a cosmic speed limit. If you try to go faster through space, you need to redirect more and more of your motion from time into space. As you approach the speed of light, you're trying to go faster and faster through space, which means you're trying to use more and more of your motion budget for space travel. but you can't use more than all of it. At the speed of light, you'd be using all your space-time motion for space and none for time. Your clock would stop completely. You'd become frozen in time. And here's the really crucial part. The mathematics of Einstein's relativity tell us that as you try to go faster and faster, the inertia of objects increases dramatically. Now, people sometimes say mass increases, and I need to correct that misconception. Mass is an intrinsic property of something. It doesn't change. But inertia, which is the resistance to acceleration, increases. And this means it takes more and more energy to push something faster and faster. If you have a rocket ship and you want to go faster, you need more and more fuel, more and more energy. This isn't because we're being clever enough in engineering the rocket. This is fundamental. The math of relativity says that to accelerate something with mass all the way to the speed of light would require infinite energy. Not a lot of energy, infinite energy. Now here's something I want to emphasize. Even an advanced alien civilization, no matter how clever, they can't get around this. They don't have infinite energy. Nobody has infinite energy. It's impossible in principle. If an alien civilization uses all the energy in their entire star system, all of it, every single bit, they still couldn't quite reach the speed of light with a massive object. They could get close, maybe 99.999% the speed of light, but never quite there. And they certainly can't go faster than the speed of light. You know why? Because there's something even deeper going on. Let me explain it a different way. Remember I said that you always travel through space-time at one fixed speed? Well, that speed is the speed of light. The speed of light isn't just the speed at which electromagnetic waves travel. It's more fundamental than that. It's the speed at which space-time itself operates. It's the speed at which causality works. It's the speed at which information can propagate. Think of it this way. If you want to know something that happened somewhere else, how do you find out about it? You have to wait for information to travel from that place to you. What's the fastest that information can travel? The speed of light. Light carries information with it, and nothing can carry information faster than light because nothing can travel faster than light. Now, this is important because of something called causality. Causality means that causes precede effects. I do something, and then something else happens as a result. The effect comes after the cause. This makes intuitive sense. You drop a ball, and then it falls. You don't see the ball on the ground and then have it lift off your hand. The order matters. But here's something remarkable. If something could travel faster than light, it would violate causality. I know that sounds strange, but let me explain. Imagine you have a spaceship that can travel faster than light. You could, in principle, use it to send a signal to the past. You could arrange things so that a signal arrives somewhere before it was sent. And then using relativity, you could send another signal back from the future to before you sent the first one. You could create paradoxes. The grandfather paradox, for instance, you could go back in time and prevent your own birth. This leads to logical contradictions. Nature doesn't permit logical contradictions. The universe doesn't allow causality to be violated. And the way it prevents this is by making the speed of light an absolute limit. Nothing can exceed it, because if something could, the structure of space-time itself would fall apart. We'd have paradoxes. We'd have effects without causes and causes without effects. The universe would be logically incoherent. So this isn't just a practical limit. It's not just that we haven't figured out how to do it yet. It's a logical limit. It's built into the very definition of what reality is. Now let me address something that often comes up. People sometimes ask about weird phenomena like quantum tunneling or the Casimir effect or these strange things that seem to allow information to go faster than light. And I want to explain why none of these actually violate the speed of light limit. In quantum mechanics, a particle can sometimes appear on the other side of a barrier without seemingly traveling through it. That's tunneling. If you calculate how long it takes, you might get a time that's less than it would take light to cross the same distance. Doesn't that mean information traveled faster than light? No. And here's why. Quantum mechanics, and I mean no disrespect to quantum mechanics because it's a beautiful theory. Quantum mechanics doesn't transmit information that way. The information you'd need to extract from the tunneling process to know that it happened requires a signal back, and that signal can't exceed the speed of light. So no information actually travels faster than light. The same goes for quantum entanglement, which is this spooky connection between particles that bothered Einstein so much. Two particles can be entangled such that measuring one instantly affects the other, no matter how far apart they are. But again, you can't use this to send information faster than light. To know the result of a measurement on the distant particle, you'd need a classical signal, and that takes normal time to arrive. The universe is clever. It allows these spooky quantum connections, but prevents you from using them to violate relativity. Nature has guardrails. And there are these proposals, speculative ones, about wormholes and warp drives that could theoretically allow faster than light travel. The idea is that you're not actually going faster than light through space. Instead, you're taking a shortcut through space. You're warping space-time itself so that the distance between 2 points becomes shorter. Conceptually, this doesn't violate relativity because locally, around the ship, nothing's going faster than light. But, and this is a big but, these ideas require exotic matter, negative energy, things we've never observed and have no idea how to create. And even if they existed, the energy requirements would be, well, let's just say you'd need something like the mass energy of Jupiter converted entirely to energy for one trip. They're not practical, not for any foreseeable future, certainly not for an alien civilization trying to cross the galaxy. So let's think about our alien friends for a moment. Let's say they're incredibly advanced. They understand physics better than we do. They've got technology that makes our current science look like Stone Age tools. What can they do? They can go very, very fast. Maybe 99.9999% the speed of light. At those speeds, amazing things happen. Time dilation becomes significant. To the aliens, a journey that takes millions of years on Earth might feel like a few months. They could, in principle, traverse the entire galaxy in a human lifetime from their perspective. That's still useful for space travel, even if it's not faster than light, but they cannot break the light barrier. They cannot go faster than light, because the barrier isn't a barrier they can overcome with better technology. It's the ultimate barrier of the universe itself. It's as fundamental as the fact that contradictions are false, as fundamental as logic. And this actually makes sense when you think about what it would mean to go faster than light. What would it mean? It would mean violating causality. It would mean allowing paradoxes. It would mean that causes could come after effects. It would mean that you could potentially know something before it happens. It would mean that the universe could be logically inconsistent. But the universe isn't logically inconsistent. As far as we can tell, it's beautifully consistent. Causality works. Effects follow causes. And this is preserved because the speed of light is constant and absolute, and nothing can exceed it. Now, I want to talk about what this means for our understanding of reality. You see, one of the things that I find most beautiful about physics is that when you really understand something, you realize it has to be that way. There's no other way it could be. And the cosmic speed limit is like that. If light could travel at different speeds to different observers, then there wouldn't be anything special about its speed. It would just be another speed, like the speed of a train or a plane. But light travels at the same speed to all observers. That's not just an observation. That's something Einstein elevated to the status of a principle. And from that one principle, everything else follows. The constancy of the speed of light, that one postulate, leads directly to time dilation. It leads to length contraction. It leads to the equivalence of mass and energy, E equals mc squared. It leads to the fact that nothing can exceed this speed. All of it flows from this one observation about light. It's like if you have a building and you discover one of the walls is really important for the structural integrity of the whole thing. If you remove that wall, the whole building collapses. Similarly, if you tried to remove the cosmic speed limit, all of relativity collapses. But not just relativity. The entire fabric of space-time, causality, the logical consistency of the universe itself collapses. So when someone asks, why can't we go faster than light? The deep answer isn't because we haven't built a strong enough engine. The answer is that the universe is structured in such a way that asking for something to go faster than light is like asking for something to be a square circle. It's not that we're limited by engineering, it's that the request is logically incoherent. And that, I think, is a remarkable and beautiful thing. Now let me come back to our alien friends one more time. Maybe they've been trying to figure this out too. Maybe millions of years ago they discovered relativity and realized the same thing we did. You can't exceed the speed of light. Maybe some of them got frustrated, just like some of us do, thinking, there must be a way around this. But the clever ones among them, the real physicists, the ones who truly understand the structure of the universe, they realize that there is no way around it. It's not a limitation they can overcome. It's the structure of reality itself. What they can do instead is become really efficient at exploring. They can develop technology that gets them to 99.9999% the speed of light. They can use relativity to their advantage, using time dilation to cross huge distances in short personal times. They can develop networks of communication that work at the speed of light. They can build space stations and colonies throughout their region of space. But they will always encounter the same universe as us, a universe where information, where light, where the very structure of reality itself has a cosmic speed limit of 186,000 miles per second. And no technology, no matter how advanced, can change that. This is, to me, one of the most profound things about physics. It's not that we've learned a trick, a clever way to do something. We've learned something about the fundamental structure of reality, and in some sense, this is a relief, because it means the universe makes sense. It's logically consistent. Causes come before effects. Information flows from past to future, and everything is held together by these beautiful, elegant laws. I find that more wonderful than faster than light travel anyway, because faster than light travel is just a technology. But the understanding that the universe has to be this way, that you can see how everything follows from the principle that light is constant, that space-time is unified, that causality matters, that understanding, that's true magic. So the next time someone asks you, why can't aliens beat the speed of light? You can tell them, it's not because they're not clever enough. It's not because they haven't found the right technology. It's because the universe itself is structured in such a way that nothing, absolutely nothing, can go faster than light. And that's one of the most beautiful discoveries we've ever made about how reality works.